In this video, we will explore the probability of discovering a diamond at the Crater of Diamonds State Park. There are several learning goals for this video. First, we will understand how to plot time series. Second, we will learn how to merge different datasets. Third, we will estimate the probability of finding different types of diamonds and calculate the expected reward. We are going to use several Python libraries, including Pandas, Matplotlib and Seaborn. The dataset contains the number of park visits and discovered diamonds from 1972 to 2023. Over the 50-year span, the park has welcomed nearly 5 million visitors and seen 36,000 diamonds discovered. Among these, 1,060 diamonds weigh over 1 carat. This means that for every 1,000 visits, 7 diamonds are found, with the average diamond weighing only 0.2 carats. Among 10,000 visitors, 2 lucky ones can find diamonds weighing over 1 carat. When we analyze the data in yearly intervals, we observe a surge in visitors after 2005, while the annual number of discovered diamonds has remained flat since 2000. Among the discovered diamonds, white is the most common color, followed by brown and yellow. This implies that the chance of discovering a diamond has been declining over the last 2 decades and has dropped to less than 5 out of every 1,000 visits. Even worse, the chance of discovering a diamond weighing 1 carat or more is no better than 1 out of every 10,000 visits. In January 2024, a French tourist discovered a huge 7.46 carat diamond in the state park. Now, let's take a look at the discovered diamonds larger than 5 carats. There are a total of 36 huge diamonds, which means that out of 1 million visitors, 7 can find a huge diamond. We can sort the findings of huge diamonds by year and merge this subgroup data with the overall dataset. Clearly, huge diamonds make up only a small fraction of all the diamonds discovered in the park. However, huge diamonds have a much higher market value than small diamonds, often worth $500,000 or more. Using the concept of expectation in probability, we can calculate the expected reward of finding a diamond, which is only around $5 per visit. However, with the park's admission fee costing $15, the reward-to-cost ratio is even worse than buying a lottery ticket from a monetary standpoint. Would you be interested in visiting the Diamond State Park and trying your luck?